The brain that is listening to these words right now is the same organ that just last night built an entire world out of nothing. It constructed rooms you have never visited, conversations with people who may not exist, and emotional experiences so vivid that your heart rate changed, your breathing shifted, your muscles tensed beneath the sheets, and when you woke, that whole elaborate architecture dissolved in seconds, gone as though it had never been. Yet, while you were inside it, you could not tell the difference. Not once did you pause in the middle of a dream and think, "This is clearly fabricated." The simulation was perfect because the simulator and the audience were the same thing. Now, consider this. The organ responsible for that flawless nightly deception is the very same organ telling you right now that what you see and hear and feel during waking hours is fundamentally different. It asks you to trust that this version of reality is the real one, but it offers no proof that was not algemated by itself. Tonight, we are going to follow that thought carefully and gently into some of the strangest territory in both philosophy and modern physics. A question that ancient Greek thinkers circled 24 centuries ago has resurfaced unexpectedly inside particle laboratories and quantum equations. The question is simple to state and impossible to settle. What if you are the only real person, not as a belief to defend, but as a possibility that neither philosophy nor physics has managed to rule out? Let that settle. We are in no rush. The night is long, and so is this thread. There is a detail about your life so obvious it rarely gets mentioned, and yet once you really sit with it, it becomes difficult to set aside. You have never experienced anything outside your own body, not once. Every sunset, every piece of music, every hand you have ever held, all of it arrived as a pattern of electrical impulses translated inside a dark sealed chamber of bone. The brain itself has no light receptors. It has no microphones. It floats in cerebrospinal fluid surrounded by absolute silence and total darkness. And it builds the entire world you think you inhabit from coded signals traveling along nerve fibers at roughly 100 meters seconds. Think about what that means for a moment. The redness of a rose does not exist in the electromagnetic wavelength bouncing off its petals. That wavelength is simply a measurement, around 700 nanometers, and it carries no color in itself. Color is something your visual cortex fabricates from that signal. It is an internal label, a tag your brain assigns so that you can distinguish one surface from another quickly enough to survive. The warmth of sunlight on your skin is not warmth in the way you experience it. It is infrared radiation absorbed by thermoreceptors, converted into nerve signals, and then rendered as a felt sensation somewhere in the somatosensory cortex. The sound of someone's voice is pressure waves in air, compressions and decompressions that your cochlea transforms into electrical patterns. Your auditory system assembles into meaning. None of these translations are optional. There is no way to bypass them and access the raw world directly. Every experience you have ever had is, in the most literal neurological sense, an inside job. And yet, it never feels that way. The world feels vividly, unmistakably out there. The coffee cup on the table feels solid and separate from you. The face of someone you love feels like it belongs to a real, independent being. This conviction that reality exists beyond your skull and you are simply perceiving it, is perhaps the deepest assumption any conscious creature carries. It is so deep that questioning it can feel almost absurd. But the brain sciences have spent the last several decades quietly demonstrating that this assumption, however useful, is not what it seems. The wall between you and the world is not transparent. It is opaque, and everything you see through it is a construction, not a window. That distinction between construction and window turns out to matter enormously. Because if everything you experience is assembled inside your own nervous system, then a very old and very uncomfortable question becomes surprisingly difficult to dismiss. How do you know there is anything out there at all? Something happens in your brain roughly 40 times each second that most people never learn about. Your visual cortex generates a prediction, a fully rendered model of what it expects to see in the next moment, and sends that prediction downward toward your eyes, not the other direction, not from eyes to brain, from brain to eyes. The incoming sensory data then gets compared against this prediction, and only the differences, the prediction errors, get passed along for further processing. This means, in a very concrete sense, that most of what you are seeing right now was not delivered by your retinas. It was generated internally, from memory, from context, from expectation, and then checked against a thin stream of incoming corrections. Neuroscientists call this predictive processing, and over the past 2 decades, it has become one of the most influential frameworks in cognitive science. What it describes is not a brain that records reality. It describes a brain that dreams reality into being, and then uses sensory data to keep the dream roughly on track. Carl Friston, a neuroscientist whose mathematical framework for this process, the free energy principle, has reshaped how researchers understand perception, puts it in terms that are almost unsettling. The brain, he suggests, is fundamentally in the business of minimizing surprise. It does not want to be wrong, so it builds the most stable, most internally consistent model it can, and then filters incoming data through that model. When the model works, you experience a smooth, seamless world. When it fails, when the prediction error is too large, you feel startled, confused, disoriented. Your brain scrambles to update. What makes this relevant to our larger question is the implication that sits quietly beneath the science. If perception is primarily a top-down construction, if the brain generates experience first and then likely corrects it, then the world as you know it is much closer to a controlled hallucination than to a direct readout of what is actually there. This is not a metaphor. The hallucination framework is taken seriously in contemporary neuroscience. Anil Seth, a researcher at the University of Sussex, has used precisely that phrase, controlled hallucination, and argues that normal waking perception and dreaming differ not in kind, but only in degree. During the day, your hallucination is constrained by sensory input. At night, those constraints are released, and the brain hallucinates freely. But the underlying mechanism is the same. Consider what this means for the question of whether other people are real. You have never perceived another person directly. You have perceived your brain's prediction of another person, updated by sensory data, assembled from memory, shaped by emotion. The face of someone sitting across from you right now is not a photograph. It is a painting your brain created using a few brush strokes of photon data and a great deal of prior experience. If perception is construction all the way down, then the distinction between a world that exists independently and a world your brain invented becomes much harder to draw than it first appears. In the winter of 1641, a French philosopher sat beside a stove in a small room in Germany and decided to doubt everything. René Descartes was not having a breakdown. He was conducting an experiment, one of the most famous in the history of thought. He wanted to find something, anything, that could not be doubted. So he began stripping away every assumption he held. Could he be certain the physical world existed? No, his senses had deceived him before. Optical illusions, phantom sounds, dreams that felt indistinguishable from waking. Could he be certain that other people existed? No, they appeared in his dreams just as convincingly as in his daily life. Could he be certain that mathematics was reliable? Not even that. For what if some powerful deceiver had arranged things so that even logic itself was a trap? Layer by layer, Descartes dismantled his world, and when he reached the bottom, only one thing remained, the act of doubting itself. If he was doubting, something was doing the doubting. Cogito, ergo sum. I think, therefore I am. The one thing that could not be an illusion was the existence of his own mind in the moment of questioning. What is less commonly discussed is what happened next. Descartes did not stop there. He desperately tried to rebuild the external world from that single hold. He argued that God, being perfect, would not allow a systematic deception of the mind, and that therefore the external world must be real. But this argument relied on assumptions that were, by his own method, unjustified. He had to smuggle in beliefs that his doubt should have excluded. Many philosophers since have pointed out that the escape hatch Descartes used was not earned. The locked door he opened was opened with a key he should not have possessed. A century later, George Berkeley took the problem further. If all we ever experience are perceptions, Berkeley asked, then what reason do we have to believe in a material world behind those perceptions? His answer was startling. There is none. The world, he proposed, consists entirely of minds and their ideas. Physical matter as an independent substance simply does not exist. Objects persist when you are not looking at them only because God is always perceiving them. Strip away the theological scaffolding, and what remains is something more severe. If you cannot rely on a divine guarantee, then you are left with a position philosophers call solipsism, the view that only your own mind is certain to exist. Everything else, including every other person, could be a feature of your experience with no independent reality behind it. This is not a position anyone comfortably holds. It is more like a philosophical gravity well, a place that pure logic slides toward when you remove enough assumptions. Descartes reached its edge and pulled back. Berkeley approached it and invoked God as a guardrail, but the pull itself has never been resolved. 24 centuries after the ancient skeptics first articulated versions of this doubt, and nearly 4 centuries after Descartes sat beside his stove, no one has produced a conclusive argument against solipsism. It remains, as the philosopher John Horgan has put it, at once utterly illogical and irrefutable, and that combination, illogical yet irrefutable, is precisely what makes it so persistent. It lingers not because anyone believes it, but because no one can quite disprove it. Somewhere in your early childhood, something remarkable happened that you almost certainly do not remember. You began to realize that other people had thoughts, not just behaviors, not just movements and sounds, but an interior world, feelings, plans, private worries, silent joys, hidden behind their eyes, just as your own inner life was hidden behind yours. Developmental psychologists call this the acquisition of a theory of mind, and most children begin showing signs of it between the ages of 3 and 5. But notice the word theory. It is not a coincidence. You did not discover other minds the way you discovered your own. You did not feel their thoughts from the inside the way you feel yours. You inferred them. You watched faces, tracked patterns, learned that certain expressions tended to mean certain things, and you built a model, an educated guess of what was happening inside someone else. That model became so automatic, so seamless, that by adulthood you barely notice it operating. When someone smiles, you feel that they are happy. When someone cries, you feel their sadness. It seems direct, immediate. It is not. It is an inference running so quickly and so unconsciously that it wears the mask of certainty. Evolutionary psychology offers a reason for why this capacity became so refined. In the social environments where early humans evolved, the ability to predict what another being would do next was a matter of survival. A creature that could model the intentions of a rival or an ally, that could guess whether the approaching figure meant harm or cooperation, had a significant advantage. The theory of mind module, as some researchers describe it, evolved not because understanding others was philosophically important, but because other beings were among the most dangerous and unpredictable variables in the environment. Empathy, at its origin, was a survival tool, a way to predict the behavior of entities whose inner states were fundamentally inaccessible, and that inaccessibility has never been breached. Not by technology, not by neuroscience, not by centuries of philosophy. You can observe someone's brain activity on a functional MRI scanner and see which regions light up during certain tasks, but you cannot see what their experience feels like from the inside. You can map every neural pathway in their cortex, and you will still be looking at structure, not at subjective experience. The interior of another mind remains, to this day, permanently beyond reach. This is what philosophers call the problem of other minds, and it is not an academic puzzle. It is the condition you live in every moment of your waking life, every relationship, every conversation. Every act of trust or love is conducted across a gap that cannot be closed. You believe that the people around you are conscious, and you are almost certainly right. But that belief is built on analogy and pattern, not on direct evidence. You assume they have an inner life because they behave like you, and you have an inner life. That is the entire foundation. It holds well enough for daily living, but it is not proof. And in the silence of a late night, when the social machinery quiets and you sit alone with your thoughts, the gap becomes harder to ignore. For most of its history, the question of whether observation shapes reality belonged exclusively to philosophers. Scientists could safely ignore it. The physical world, as far as classical physics was concerned, was simply there, solid, measurable, indifferent to how it was looking. A rock was a rock, whether or not anyone noticed it. The moon did not vanish when you turned away. And then, in the early 20th century, something happened in the laboratories that changed this. The experiment is famous enough that even people who have never studied physics have heard of it. Send a stream of particles, photons, electrons, even molecules, toward a barrier with two narrow slits. When no one monitors which slit each particle passes through, the particles produce an interference pattern on the detection screen behind the barrier. This is the signature of a wave. The particles individually seem to pass through both slits simultaneously, interfering with themselves the way ripples in water overlap. But place a detector at the slit, something that records which path each particle takes, and the interference pattern disappears. The particles now behave as discrete objects, each passing through one slit or the other. The simple act of gathering information about the particle's path changes what the particle does. This is the double-slit experiment, and it remains one of the most discussed results in all of physics. Richard Feynman, who understood quantum mechanics as deeply as anyone, called it a phenomenon which is impossible to explain in any classical way, and which has in it the heart of quantum mechanics. Now, here it is important to slow down and be careful with the word observer. In popular descriptions, this experiment is often presented as though human consciousness collapses the wave function, as though the particle behaves differently because a mind is watching. This is a misunderstanding, but it is a misunderstanding that reveals something genuine. What actually matters is the physical interaction required to obtain the information. To determine which slit a photon passes through, you must interact with it, scatter another photon off it, or use some other physical process that leaves a trace. That interaction disturbs the system. It is the measurement device, not the human watching the measurement device, that changes the outcome. And yet, the deeper question does not go away so easily. Because when you pull back far enough, you have to ask, what counts as a measurement? At what point does a physical interaction become the kind of interaction that selects a definite outcome from a range of possibilities? A photon hits a detector. The detector registers a signal. The signal travels to a computer. The computer displays a number on a screen. A human reads the number. Where in that chain does possibility become fact? The equations of quantum mechanics do not say. They describe the evolution of possibilities with extraordinary precision, but they contain no instruction for when or how one possibility becomes the one that actually happens. This silence in the mathematics, this gap between what the equations describe and what we actually experience, is where things begin to get strange. And it is where, quite unexpectedly, the ancient question of solipsism finds its way into a physics laboratory. There is a feature of quantum mechanics that physicists have been quietly arguing about for nearly a century, and it is worth stating plainly because it sits at the center of everything we are exploring tonight. The equations that describe the quantum world, the Schrawa-K-Dinger equation primarily, are perfectly deterministic. Given a quantum system and its initial state, the math tells you exactly how that system will evolve over time. There is no ambiguity, No randomness, no mystery in the equation itself. But what the equation describes is not a single outcome. It describes a superposition, a mathematical combination of many possible outcomes, each with an associated probability. An electron is not in one place. It is, according to the equation, in a weighted blend of many places at once. A photon is not polarized in one direction. It exists as a combination of all its possible polarizations, each contributing to the overall state. And then someone measures it, and when they do, they find a single definite result. The electron is here, not there. The photon is polarized this way, not that way. One outcome, sharp and specific, emerges from the blur of possibilities. The equation does not describe this transition. Nothing in the mathematics explains why or how the superposition resolves into a single observed value. The Schrödinger equation, applied without interruption, would predict that the measuring device itself enters a superposition, and then the laboratory, and then the physicist, and then the wider world, an ever-expanding wave of possibilities that never collapses into a single reality. This is the measurement problem, and it is not a minor technical detail. It is the deepest open question in the foundations of physics. After 100 years of quantum theory, there is no consensus on what happens when a measurement occurs. There are interpretations, many of them, each with passionate defenders, but none has been proven, and all of them carry implications that would have seemed extraordinary to the physicists who first encountered this puzzle. What makes the measurement problem quietly relevant to the question of solipsism is the gap it leaves. If the equations describe only possibilities, and a definite reality emerges only upon measurement, then the process by which your experience becomes definite, by which the world you perceive takes on its crisp singular character, is not explained by the physics. Something outside the equation is doing the selecting, and the only candidate that cannot be removed from the process is the observer. This does not mean that consciousness caused collapse. That is a much stronger claim than the physics supports. But it means that the observer cannot be cleanly separated from the system being observed. The neat division between a world that exists objectively and a mind that passively watches it, the division that classical physics took for granted, does not survive the transition to quantum theory. In the space left by that dissolution, something old and disquieting stirs. Because if definite reality requires an observer, and you are the only observer whose existence you can verify, then the question of whether your consciousness plays a special role in the emergence of the world is no longer purely philosophical. It has become, whether physicists are comfortable with it or not, a question that touches the foundations of the physical theory itself. In 1961, the Hungarian-American physicist Eugene Wigner published a thought experiment so strange that even he seemed uncomfortable with its implications. It has since become one of the most debated scenarios in the philosophy of physics, and it begins simply enough. Imagine a physicist, Wigner's friend, sealed inside a laboratory. She performs a quantum measurement. Perhaps she measures the spin of an electron, up or down, according to standard quantum mechanics. Before the measurement, the electron is in a superposition of both states. When the friend measures it, she sees a definite result, spin up, let us say. For her inside the laboratory, the experiment is over. The electron has a definite property. The world is clear, but now consider Wigner standing outside the sealed lab. He has not opened the door. He has not communicated with his friend. From his perspective, the entire laboratory, including the friend, including her brain, including the electron, is a quantum system. And because he has not interacted with any of it, the rules of quantum mechanics say that the whole system is still in superposition. For Wigner, the friend has not yet seen a definite result. She exists mathematically in a blend of states, one version of her who saw spin up and another who saw spin down, two descriptions of the same moment. One observer experiences a definite reality. The other observer, applying the same physical laws, describes that first observer as still suspended between possibilities. Which account is correct? Wigner himself initially suggested that consciousness must be the ingredient that collapses the superposition, that his friend's awareness forced a definite outcome into being. But this raised more problems than it solved. Whose consciousness counts? How much awareness is needed? Does a cat count? An amoeba? The proposal felt more like a retreat than an explanation. What remained, though, was the paradox itself, and it did not go away. In 2019, a team of physicists at Griffith University in Australia constructed a real experiment that tested an extended version of this scenario using entangled photons. Their results confirmed something deeply counterintuitive. When different observers apply quantum mechanics consistently, they can arrive at mutually contradictory conclusions, and both can be justified by the formalism. There does not appear to be a single observer-independent fact about what happened. This is not a failure of the experiment. It is a feature of the theory. Quantum mechanics, applied universally, seems to permit different observers to inhabit different realities, not as a metaphor, but as a mathematical consequence. Sit with that for a moment. The physics that describes the most fundamental layer of the material world does not guarantee that two people observing the same event will agree on what occurred. Reality, at the quantum level, may not be a single shared thing. It may be perspectival, dependent on who is asking and what they have interacted with. And if reality is perspectival, the distance between mainstream physics and the ancient suspicion of solipsism becomes uncomfortably small. There is an experiment that John Archibald Wheeler spent years thinking about, one he discussed late into his life with a kind of reverent unease, and it involves something that feels at first like a contradiction, the idea that a choice you make right now can determine what happened in the past. The setup is a variation of the double-slit experiment. A single photon is sent toward a barrier with two slits. After the photon has already passed through the barrier, after it has, in some sense, already committed to a path, you make a decision. You choose whether to place a detector that determines which slit the photon went through, or to leave the detection screen untouched and allow the interference pattern to form. If you choose the detector, the photon behaves as though it went through one slit, a particle with a definite path. If you leave the screen, the photon behaves as though it went through both slits simultaneously, a wave interfering with itself. The striking thing is that this choice is made after the photon has already traversed the slits. The decision comes too late by any classical understanding of time to affect the photon's behavior. And yet the results consistently show that the photon's past behavior corresponds to your present choice, as if the future were reaching back to adjust history. Wheeler was deeply moved by this. He wrote that the past has no existence except as it is recorded in the present, not as a philosophical opinion, but as something the experiments seem to demand. The photon does not have a definite history until that history is called into being by a present act of observation. This was not, for Wheeler, evidence of mysticism. He was one of the most rigorous physicists of the 20th century, the man who coined the term black hole, who worked alongside Niels Bohr and Albert Einstein, who helped develop the theory of nuclear fission. But late in his career, he began to suspect that the relationship between observer and reality was far deeper than anyone had imagined. He proposed what he called a participatory universe, not a universe that exists fully formed and waits for observers to appear within it, but a universe that is, in some fundamental way, brought into being by the act of observation. The observer, Wheeler suggested, is not a late addition to the cosmic story. The observer is a participant in the creation of the story itself. This is a thought that does not resolve cleanly. It does not collapse into a simple claim, and perhaps that is the point. Wheeler did not insist on a final answer. He insisted on the question, and the question, can the present shape the past, remains open in the same way a door left slightly ajar remains open. You cannot see what is on the other side, but you can feel the draft. Late in his life, after decades of working at the deepest levels of gravitational physics and quantum theory, John Wheeler arrived at a phrase that he believed might hold the key to everything. 3 small words, it from bit. The idea was radical, and Wheeler knew it. He proposed that the physical world, all the matter, all the energy, all the space-time geometry that makes up the universe, does not exist as a primary thing. Instead, it emerges from something more fundamental, information, specifically binary information. Yes or no answers to questions that participants pose to nature through acts of observation. Every particle, every field, every measured quantity, Wheeler suggested, derives its existence from the answers to such questions. An electron does not carry its spin as a permanent property the way a ball carries its color. The spin becomes definite only when a question is asked, when a measurement is performed, and the answer is registered as a bit of information. The electron's reality, in this view, is not something it possesses. It is something that is generated by interaction. This was not merely philosophy dressed in physics language. Wheeler connected it to deep results in quantum mechanics and information theory. The discovery that black holes have entropy, that they carry information proportional to their surface area, not their volume, suggested to him that the fabric of space-time itself might be woven from informational threads. The later development of the holographic principle, which proposes that all the information in a region of space can be encoded on its boundary, lent further weight to the intuition that bits might be more fundamental than atoms. What makes this perspective relevant here? In the middle of the night, in the context of this particular question, is what it implies about observers. In a universe built from matter, observers are incidental. They are latecomer arrangements of atoms that happen to be complex enough to notice things. But in a universe built from information, from answers to questions, observers are essential. Without someone or something to ask the question, there is no answer. Without an answer, there is no bit. Without the bit, there is no it. Wheeler described this with a drawing he called participatory universe, a large letter U with an I at one end looking back at the other. The universe gives rise to observers. Observers, by asking questions, give rise to the information that constitutes the universe. A closed loop. Neither side comes first. This is not solipsism in the traditional sense. Wheeler was not suggesting that your individual consciousness dreamed up the cosmos, but the framework does something subtle and important. It removes the possibility of a universe that is fully real in the absence of any observer whatsoever. It places participancy, the act of asking and registering, at the foundation of physical existence. And once that foundation is laid, the question of how many observers are needed and whether your particular observer status is unique begins to carry a different weight. The question is no longer just philosophical. It is structural. It concerns the very architecture of what we mean when we say something is real. There is a phenomenon in physics that Albert Einstein once called spooky action at a distance, and his discomfort with it lasted for the rest of his life. He believed it was a sign that quantum mechanics was incomplete, that something was being missed, some hidden variable that would restore the clean, local, separable world he trusted. He was wrong. The phenomenon is real, and its implications stretch far beyond the laboratory. Quantum entanglement occurs when two particles interact in such a way that their quantum states become linked. After this linking, the particles can be separated by any distance, across a room, across a continent, across a galaxy, and a measurement on one will instantaneously correlate with the state of the other. Not after a delay, not at the speed of light, instantaneously. For decades, the question was whether this correlation was truly fundamental, or whether it could be explained by some pre-existing shared property, a hidden instruction set baked into the particles at the moment of their interaction. In 1964, the physicist John Bell devised a mathematical inequality that could distinguish between these possibilities. If the correlations between entangled particles exceeded a certain threshold, then no hidden variable theory could explain them. The entanglement would have to be genuinely non-local, a real connection that defied classical intuitions about separability. Experiments testing Bell's inequality began in the 1980s and continued for decades, each one closing a potential loophole. And in 2022, the Nobel Prize in Physics was awarded to Alain Aspect, John Clauser, and Anton Zeilinger for their experimental confirmation that Bell's inequality is violated. Non-locality is not a theoretical curiosity. It is an established feature of the physical world. Now, what does this have to do with solipsism? On the surface, very little. Entanglement is a physical phenomenon. Solipsism is a philosophical position. But look closer. What entanglement demonstrates is that the boundaries we draw between separate objects, the conviction that one thing is here and another thing is there, and they are fundamentally distinct, do not hold at the quantum level. Two entangled particles are not two independent entities with independent properties. They are, in some deep sense, aspects of a single system that does not respect the spatial separation we see. If the physical world does not treat separation as fundamental, then the sharp line between self and other, the line that makes solipsism feel meaningful, begins to seem like a feature of perception rather than a feature of reality. The sense that you are a distinct, bounded entity encountering other distinct, bounded entities may be a macroscopic approximation, useful for navigating the world, but not reflective of what the world actually is at its most basic level. This does not disprove solipsism, but it reframes the question. Perhaps asking whether you are the only real person is already assuming a kind of separateness that the physics does not support. Perhaps the deeper question is whether the boundaries between persons are as real as they feel. If quantum mechanics tells us that particles exist in superpositions, blends of many possible states at once, then there is an obvious question that follows. Why does the world you experience feel so solid, so singular, so stubbornly definite? You never see a chair in a superposition of being in two places at once. You never experience yourself simultaneously taking the left path and the right path. Your entire lived experience is one of crisp, classical reality, a single thread of events, each following the last in clear sequence. The answer, or at least a large part of it, comes from a process called decoherence, and understanding it helps clarify both what quantum mechanics does explain and what it does not. Decoherence occurs when a quantum system interacts with its environment. When an electron exists in a superposition inside a carefully isolated laboratory apparatus, it can maintain that superposition because it is shielded from outside interference. But the moment it interacts with surrounding air molecules, photons, or any part of the larger environment, its quantum state becomes entangled with all those environmental particles. The delicate phase relationships that produce quantum interference effects, the ghostly, wave-like behavior, get dispersed into the environment so rapidly and so thoroughly that they become, for all practical purposes, undetectable. The result is that the system appears to be in a single, definite state. The superposition has not been destroyed, strictly speaking. It has been diluted into such an enormous number of environmental degrees of freedom that recovering it would require tracking every particle in the surrounding air, every photon that bounced off the apparatus, every thermal vibration in the walls of the room. In practice, this is impossible, and so the world looks classical, definite, real. This explains a great deal. It explains why quantum effects are visible only in carefully controlled laboratory settings and not in daily life. It explains why the transition from quantum possibility to classical appearance happens so quickly on time scales of femtoseconds for most macroscopic objects. It explains why you never see a cat that is both alive and dead, but there is something decoherence does not do, and this matters. Decoherence does not select which outcome becomes real. It explains why you do not see the alternatives, but it does not explain why you see this particular outcome rather than another. The mathematics of decoherence shows the superposition spreading to the environment, not resolving into a single result. After decoherence has done its work, you are left with a set of possible outcomes that no longer interfere with each other, but the question of why one of them is experienced as actually happening remains unanswered. This is sometimes called the problem of definite outcomes, and it is precisely the part of the measurement problem that decoherence was hoped to solve but does not. The world feels solid not because quantum mechanics has been overridden, but because the quantum strangeness has been hidden, tucked away into environmental correlations too vast to observe. The solidity is real as experienced. Whether it is real in any deeper sense remains an open question, one that leads naturally into the interpretations of quantum mechanics that have been devised over the past century to fill that silence. In the late 1920s, when quantum mechanics was still new and its creators were still arguing about what their own equations meant, the physicist Niels Bohr made a decision that shaped the entire future of the field. He decided not to explain. This is not quite how it is usually described. The standard account says that Bohr and his colleagues in Copenhagen developed an interpretation of quantum mechanics, the Copenhagen interpretation that provided a coherent philosophical framework for the new physics. But what Bohr actually did was something subtler and in some ways more radical. He drew a line. On one side of that line was the quantum system, the particles, the wave functions, the superpositions. On the other side was the measurement apparatus and the observer, the classical world of definite outcomes and solid objects. And he insisted that the two sides operated under fundamentally different rules. The quantum world was described by the Schreier-Haidinger equation. The classical world was described by ordinary experience. The moment of measurement, the point at which quantum possibility became classical actuality, was acknowledged as real but not explained. It was treated as a brute fact. You perform a measurement, you get a result. Do not ask what the system was doing before the measurement. That question, Bohr maintained, was not meaningful. This was not evasion born of laziness. Bohr had thought deeply about the limits of language and the relationship between observer and observed. He was influenced by philosophical traditions that questioned whether human concepts developed to navigate a macroscopic world could be meaningfully applied to a realm that operated on entirely different principles. His position was that quantum mechanics was not a description of an observer-independent reality. It was a description of the results of observations. Physics, in this view, tells you what you will find when you look. It does not tell you what is happening when you are not looking. There is an overlooked nuance here that matters for our journey tonight. Bohr was not claiming that consciousness creates reality. He was making a more careful, and in some ways, more disturbing point. He was saying that the question, what is really going on when no one is looking, may not have an answer, not because we lack the tools to find it, but because the question itself may be malformed, like asking what is north of the North Pole. This refusal to answer has frustrated physicists for generations. Einstein found it intolerable. He famously asked whether the moon exists when nobody is looking at it. Bohr's implicit response was that the question presupposes a kind of reality that quantum mechanics does not support. And in that refusal lives something relevant to the thread we are following. Because if physics cannot tell us what reality is doing when no one observes it, if the most successful physical theory in history only describes what observers experience, then the observer is not a peripheral character in the story of the universe. The observer is the only character for whom the story is told. This is not solipsism, but it is closer to solipsism than most physicists are comfortable admitting. And the discomfort has not faded with time. It has only grown quieter. Among all the interpretations of quantum mechanics debated in university seminars and physics conferences, there is one that provokes a reaction unlike any other. When people first encounter it, the most common response is some version of, "Isn't that just solipsism?" The interpretation is called cubism, originally short for quantum Bayesianism, and it was developed primarily by the physicist Christopher Fuchs, along with collaborators Carlton Caves and Ron Fordiger-Shack. It is elegant, internally consistent, and profoundly unsettling in what it asks you to accept about the nature of reality. The core claim of cubism is this: the quantum state, the mathematical object that physicists use to describe a system, is not a description of the system. It is not a fact about the world. It is a tool that an individual agent uses to organize their expectations about theoretic future experiences. When a physicist writes down a wave function, they are not mapping reality. They are encoding their personal beliefs about what they might encounter next. And the Born rule, the equation that converts quantum states into probabilities, is not a law of nature. It is a normative rule, like the rules of good gambling. It tells you how a rational agent should update their expectations when they receive new information. In this framework, the measurement problem dissolves, not because it has been solved, but because it was never a real problem to begin with. If the quantum state was never a description of an objective reality, then there is nothing objective to collapse. When you perform a measurement and get a result, you have not caused a physical event in the outside world. You have had an experience, and you update your personal quantum state accordingly. The collapse is epistemic, a change in belief, not a change in the world. This is where the accusations of solipsism begin. If the quantum state is personal, if measurements are personal experiences, if there is no shared objective state that all observers agree upon, then is cubism saying that each person lives in their own private reality? Fuchs has responded to this charge repeatedly and with considerable energy. He has coined the term participatory realism to describe the picture that cubism paints. The world, in his view, is not a construction of individual minds. It is something real that pushes back against us when we act upon it. But it is not a world of predetermined properties waiting to be discovered. It is a world that comes into sharper focus through our participation, through the act of asking questions and experiencing answers. The reality is real, but it is not fully determined in advance. Each agent's engagement with it brings something genuinely new into being. The physicist David Mermin, who became a prominent advocate of cubism late in his career, addressed the solipsism charge directly. "My experience of you," he wrote, "leads me to hypothesize that you are a being very much like myself, with your own private experience. Science, in the cubist view, is a collaborative human effort to find, through individual actions on the world, and verbal communication with each other, a model for what is common to all of our privately constructed external worlds. There is something both liberating and dizzying in this. It means the universe is not a script being read aloud by passive observers. It is an improvisation. Each participant contributes something that was not predetermined. And if that is the case, then the solipsist fear that you are alone in a universe of your own making misses the point. You are alone in your experience, yes, but your experience is of something that resists you, surprises you, and exceeds your expectations. Whatever that something is, it is not you. There is an interpretation of quantum mechanics that most people, even those who follow physics closely, have never heard of. It was proposed by the French physicist and epistemologist Hervé Zwern, and its name is so unusual that it almost sounds like a contradiction: convivial solipsism, the solipsism of good company. Zwern begins where many physicists end, with the measurement problem and the realization that no existing interpretation fully resolves it, without introducing something philosophically radical. The Copenhagen interpretation draws an arbitrary line between quantum and classical. Many worlds posits an infinity of unobservable branches. Collapse theories modify the equations with new physics that has never been detected. Each interpretation solves one problem by creating another. Zwern's approach is to accept what the formalism actually says, adding hidden structure, and without pretending the problem is smaller than it is. And what the formalism says, when taken seriously and applied universally, is that the results of quantum measurements are relative to the observer who performs them. This is where it gets interesting. In convivial solipsism, each conscious observer inhabits their own branch of quantum outcomes. When you measure a particle and see spin up, that result is real for you. But the formalism does not require that every other observer has entered the same branch. From the perspective of the mathematics alone, each observer experiences their own definite reality, and these realities are private. This sounds like a recipe for chaos, a universe in which everyone lives in incompatible worlds and no shared reality exists. But here Zwern makes a careful and crucial point. Quantum mechanics does not merely allow private realities. It also guarantees that those private realities will be consistent with each other whenever observers compare notes. If you measure a particle and find spin up, and later tell a friend your result, the physics ensures that your friend will hear you say spin up. The branches do not clash. The private experiences do not contradict. The word convivial is chosen with precision. It means sociable, companionable, having the quality of being able to coexist pleasantly. Zwern's claim is that quantum mechanics describes a universe in which each observer is, in a strict sense, solipsistically enclosed within their own set of outcomes. And yet, the structure of the theory guarantees that these enclosures are harmonious. You are alone in your experience, but you are never in conflict with anyone else's aloneness. This is a strange kind of comfort. It does not offer the reassurance of a single objective world that everyone shares, but it does offer something else. The assurance that even if reality is perspectival, even if what you see is, at bottom, yours alone, the perspectives fit together seamlessly. The isolation is real, but it is a sociable isolation, a solitude that plays well with others. What makes Zwern's proposal particularly relevant is that it does not require any new physics. It does not modify the Schrödinger equation. It does not add hidden variables or collapse mechanisms. It simply takes the existing formalism at face value and follows the implications honestly. And the implications honestly followed lead to a picture that is solipsistic in structure but shared in practice. Perhaps this is as close as physics can come to describing what the experience of being a conscious being in this universe actually feels like. Private on the inside, consistent on the outside alone, but convivially so. In 1996, the Italian physicist Carlo Rovelli published a paper that began with a deceptively simple idea and ended somewhere very far from where most readers expected. The idea was this: what if the properties of a physical system are not absolute? What if they exist only in relation to another system? This is relational quantum mechanics, and while it shares some surface similarities with cubism and convivial solipsism, it comes from a different direction and arrives at a subtly different conclusion. Rovelli's starting point is not consciousness, not agents, not experience. His starting point is physics itself, specifically the observation that quantum mechanics already treats measurements as interactions between systems, and that there is no reason to privilege any one system's perspective over another. In classical physics, a particle has a position. That position is a fact, the same for everyone, everywhere, regardless of who measures it or how. Relational quantum mechanics proposes that this is wrong. A particle's position is not a property of the particle alone. It is a property of the relationship between the particle and the system that interacted with it. If a different system interacts with the same particle in a different way, it may find a different value, and both values are equally valid. This is not a minor adjustment. It is a foundational shift. It means there is no God's eye view of the universe, no description of reality that is true from all perspectives simultaneously. Each physical system has its own account of the world, determined by its own history of interactions, and these accounts may differ. Rovelli is careful to distinguish this from solipsism. In relational quantum mechanics, the subject is not a mind. It is any physical system, an electron, a grain of sand, a measuring apparatus. There is nothing special about human consciousness in this framework. The relativity of physical facts applies to all interactions, not just those involving awareness. A rock interacting with another rock encounters a relational reality just as much as a physicist interacting with an electron does, and yet the philosophical consequence is difficult to avoid. If there is no objective, mind-independent description of reality, if every fact is a fact relative to a particular interaction, then the notion of a shared world independently of all observers becomes at best an approximation. What exists in Rovelli's framework is not a world. It is a vast web of relations, each one generating its own fragment of reality, each fragment as valid as any other. Rovelli has written that the world is not a collection of things. It is a collection of events, of happenings, of interactions. The solid objects of our daily experience, table, the chair, the person sitting across from you, are not permanent entities with intrinsic properties. They are patterns of interaction, stable enough to seem solid, persistent enough to feel real. There is something both humbling and strangely peaceful in this. If the universe is relational all the way down, then nothing exists in isolation. Not a particle, not a planet, not a person. Existence itself becomes something that happens between things, not within them. And the question of whether you are the only real person begins to shift, not towards solipsism, and not away from it, but toward a third possibility, that the concept of being a separate person may not survive a careful examination of what the physical world actually is. There is a cognitive scientist at the University of California, Irvine, who has spent decades making a claim that when you first hear it, sounds almost irresponsible. Donald Hoffman argues that nothing you perceive is real, not approximately real, not close to real, not a rough sketch of something real, none of it. The colors, the shapes, the spatial layout, the solid objects you navigate around every day, all of it, he claims, is a species-specific user interface that has nothing to do with the underlying nature of reality. His argument comes not from philosophy, but from evolutionary game theory. Working with the mathematician Chetan Prakash, Hoffman devised what they call the fitness beats truth theorem. Using computer simulations of natural selection, they tested whether organisms that perceived reality accurately would outcompete organisms that perceived only fitness-relevant information, simplified symbols, tuned not to truth, but to survival. The result was striking. In every simulation across every environment they tested, truth went extinct. Organisms that saw reality as it actually was died out. Organisms that saw useful fiction survived. The implication is that evolution did not design your perceptual systems to show you the world. It designed them to show you a desktop, an interface made of icons that guide behavior. When you see a red apple, you are not perceiving an object as it fundamentally is. You are seeing a fitness icon, a symbol your brain generates to help you make decisions that increase your chances of survival and reproduction. The apple as you see it is no more similar to the underlying reality than a file icon on your computer screen is similar to the actual voltages and magnetic charges stored on the hard drive. This might seem unrelated to quantum physics, but the connection is deeper than it first appears. If perception is not a window onto reality, but a survival interface, then the very framework through which you assess whether other people are real is itself not a truth-tracking system. You do not see other people. You see your brain's fitness-relevant rendering of whatever the underlying reality is. And you have no way to get behind the rendering to check what is actually there. Hoffman takes this even further. He proposes that space-time itself, the stage on which all of physics plays out, is part of the interface, not part of the underlying reality. In his framework, what exists beneath the desktop is not particles or fields or space-time geometry. It is something more abstract, a network of conscious agents whose interactions generate the world we experience, the way software interactions generate the images on a screen. This is, admittedly, speculative territory. Hoffman's framework is not established science in the way that quantum mechanics is, but the fitness beats truth theorem rests on solid mathematics, and its implication that your senses were never designed for truth does not require accepting the full framework to take seriously. and it does something important for our question. It narrows the gap between the solipsist position and ordinary experience. If you are already living inside a constructed interface that bears no necessary resemblance to whatever is actually out there, then the difference between saying reality is constructed and saying reality might be personal is a matter of degree, not of kind. The wall between you and the world was never transparent, and the question of what, if anything, exists on the other side remains as open as it has ever been. In 1957, a graduate student at Princeton named Hugh Everett III proposed something so bold that his own doctoral advisor, John Wheeler, spent years trying to soften its impact before publishing it. Everett's idea was, in one sense, the simplest possible response to the measurement problem. He suggested that the wave function never collapses, not ever, not for any reason. In Everett's framework, when a quantum measurement is performed and the equations say the system is in a superposition of outcomes, all of those outcomes actually happen. The universe splits. In one branch, the electron is spin up. In another, it is spin down. Both branches are equally real. Both continue evolving according to the Schrödinger equation, and the observer, the person performing the measurement, also splits. One version of them sees spin up. Another version sees spin down. Each version is fully conscious, fully real, and completely unaware of the other. This is the many worlds interpretation, and it has become one of the most popular frameworks among physicists working in quantum foundations and quantum computing. Its appeal is that it adds nothing to the formalism. There are no collapse mechanisms to explain, no measurement problem to solve. The equation is the equation, and reality is everything the equation describes. But there is a feature of many worlds that is rarely discussed outside of specialized philosophy, and it touches directly on the question we have been following all night. In the many worlds framework, every quantum event causes the universe to branch, not just in laboratories, everywhere, constantly, at every moment. Every interaction between every particle creates a new fork. The number of branches is not merely large, it is uncountably infinite, and your consciousness, whatever that is, follows only one path through this infinite tree. This means that your experience timeline, the specific sequence of events that constitutes your life, is literally unique. No other observer in any branch shares your exact path. The universe you inhabit, defined by the particular set of outcomes you have experienced, is yours alone, not metaphorically, structurally. This is a form of solipsism that hides inside a theory that was designed to be the most objective interpretation possible. Everett removed the observer from any special role. He insisted that the physics treats all systems equally. There are no measurements, no collapses, no special events, and yet the result from the inside is a universe in which each observer's reality is private and unrepeatable. If every possible outcome happens somewhere, then the question what is real loses its sharpness. Everything is real, but the question what is real for me becomes fundamental. Your specific reality, the branch you inhabit right now, the particular world you experience, is not shared with any other version of anyone else. It is the product of a unique path through an infinite labyrinth, and the many worlds interpretation offers no way to communicate across branches. There is no vantage point from which all branches are visible simultaneously. Each observer is confined to their own thread of the tapestry, unable to verify that the other threads exist. Perhaps this is what solipsism looks like when translated from philosophy into physics. Not a lonely mind imagining a universe, but a real universe so vast that each mind within it occupies a private corridor, infinitely long, infinitely thin, and uniquely its own. In the late 19th century, the Austrian physicist Ludwig Boltzmann was wrestling with one of the most fundamental questions in physics. Why is the universe so orderly? The second law of thermodynamics tells us that entropy, disorder, tends to increase over time. Left alone, systems move from ordered states toward disordered ones. Hot coffee cools, neat rooms become messy, stars burn out, and yet here we are in a universe filled with galaxies, planets, complex molecules, and conscious beings. The order is extraordinary, and Boltzmann wanted to know where it came from. His answer was bold and, at the time, reasonable. In an infinite universe existing over infinite time, he suggested, random fluctuations would occasionally produce pockets of low entropy, regions of temporary order that arise by chance from the chaos. Our observable universe, he proposed, might be one such fluctuation, a brief, improbable eddy of order in an otherwise disordered sea. The idea was elegant, but it contained a problem that would not surface for another century. And when it did, it struck at the heart of everything we think we know about our own existence. The problem is this: if random fluctuations can produce an entire observable universe, they can also produce something much smaller and much more probable, a single brain, a disembodied brain floating in the void, complete with neurons, synapses, and, crucially, a full set of false memories, memories of a childhood that never happened, memories of a world that does not exist, memories of reading a passage just like this one in a life that was never lived. Such an entity has come to be called a Boltzmann brain, and the disturbing statistical reality is that in a universe governed by random fluctuations over long enough timescales, Boltzmann brains would outnumber real observers by an almost unimaginable margin. The probability of randomly assembling a single brain with false memories is inconceivably small, but the probability of randomly assembling an entire universe of the kind we observe is far, far smaller still. So, if you are comparing likelihoods, you are more likely to be a Boltzmann brain than a person living in a real universe. Cosmologists do not actually believe they are Boltzmann brains. The concept is used as a reductio ad absurdum, a test for physical theories. If a theory predicts that Boltzmann brains should vastly outnumber normal observers, that theory is considered to have a problem. Physicists like Sean Carroll have argued that the Boltzmann brain scenario should be treated as a sign that something in the underlying cosmological model is wrong. But the discomfort lingers because the argument against being a Boltzmann brain is not empirical. You cannot run a test. You cannot scan your surroundings and confirm that they are genuine, rather than a spontaneous fluctuation that will dissolve in the next instant. Every piece of evidence you might cite, every memory, every perception, every scientific measurement could be part of the false architecture. This is cosmology's own solipsism crisis, the possibility that your entire experienced reality is self-contained, self-generated, and connected to nothing outside itself. Not because of philosophical speculation, but because of the mathematics of entropy and probability. And while most physicists set the thought aside as an interesting pathology of certain models, the fact that it arises at all from rigorous physics is itself worth sitting with here in the dark. Picture someone you know well, someone whose face you could draw from memory, whose voice you could recognize in a crowd, whose habits and reactions are familiar to you in the way that only years of close contact can produce. Now, imagine that this person is, in every physical detail, exactly as you know them, the same neurons, the same synaptic connections, the same electrochemical activity down to the last molecule. But there is one difference. There is nothing it is like to be them, no inner experience, no feelings, no awareness. The lights are on, but no one is home. This is the philosophical zombie, a thought experiment introduced most prominently by the philosopher David Chalmers in the 1990s, though versions of it have existed in philosophical discourse for longer. The philosophical zombie, or P-zombie, is not the shambling figure of horror films. It is something more unsettling. It is a being that is functionally indistinguishable from a conscious person, but has no subjective experience whatsoever. It talks about feelings, but feels nothing. It recoils from pain, but there is no suffering. It says the sunset is beautiful, but nothing appears to it at all. The question Chalmers poses is not whether such a being actually exists. The question is whether it is conceivable. Can you imagine, without contradiction, a being that is physically identical to you, but lacks inner experience? If the answer is yes, if a philosophical zombie is even logically possible, then consciousness is not something that follows automatically from physical arrangement. You could assemble all the atoms in exactly the right configuration, wire all the neurons exactly as they are in a human brain, and still end up with a being that has no interior life. Consciousness in this case would be something additional, something beyond. This matters enormously for the solipsism question, because if consciousness does not reduce to physical structure, then there is no physical test you could ever perform to determine whether someone is conscious. You can scan a brain and observe its activity. You can measure responses and catalog behaviors, but none of these measurements access the interior, the felt quality, the what its likeness of experience. You are always observing the outside, and this means that the problem of other minds is not merely a philosophical inconvenience. It is a structural feature of any universe in which consciousness is not identical to its physical substrate. No matter how sophisticated your instruments become, no matter how complete your model of another person's brain, you will never be able to confirm from the outside that there is something it is like to be them. You will always be guessing. Some philosophers reject the zombie thought experiment entirely. Daniel Dennett, for instance, argues that if a being is physically identical to you, it is conscious by definition, that there is no room for the lights to be off if all the circuitry is the same. But even Dennett acknowledges that consciousness resists explanation in a way that other phenomena do not. We can explain digestion, immune response, photosynthesis, all the way down to molecular mechanisms. But explaining why certain brain processes produce subjective experience remains a different kind of problem entirely. And as long as that problem remains unsolved, solipsism retains its foothold, not as a position anyone endorses, but as a possibility no one can exclude. The darkness behind another person's eyes, whether it contains a universe of experience or nothing at all, is something you will never directly see. There is a particular kind of question in science that feels solvable, a hard puzzle, maybe, but the kind of puzzle that yields to persistence and ingenuity. How does a protein fold? What is the structure of a black hole's interior? How did life begin from non-living chemistry? These are difficult, but they belong to a category where the path to an answer, even if unclear, feels like it exists. We know what kind of evidence would count. We know what a solution would look like. And then there is the hard problem of consciousness, which the philosopher David Chalmers named in 1995, and which remains unlike any other open question in the sciences. It is not a problem of mechanism. It is a problem of existence. The easy problems of consciousness, which are not easy at all, but merely easier by comparison, involve explaining how the brain processes information, discriminates between stimuli, integrates data, and controls behavior. These are questions about function, and neuroscience is making genuine progress in them. We understand more about visual processing, memory formation, and attention networks with each passing year. The hard problem asks something different. It asks why any of this processing is accompanied by subjective experience. Why does it feel like something to see the color red? Why is there an interior to your experience at all? A computer can process information, discriminate between inputs, and generate appropriate outputs. But presumably there is nothing it is like to be that computer. What is it about the biological brain that gives rise not just to function, but to feeling? Nothing in our current scientific framework explains this. You can describe the neural correlates of consciousness, the specific brain states that accompany specific experiences, but correlation is not explanation. Saying that activity in the visual cortex correlates with the experience of seeing blue does not explain why that activity produces the subjective sensation, rather than occurring in the dark without any felt quality at all. This is not a temporary gap. It is a conceptual barrier. The vocabulary of physics, particles, forces, fields, space-time does not contain the concept of experience. You cannot derive the redness of red from any equation, no matter how detailed. The subjective character of experience seems to be something that physical description, by its very nature, does not capture. And here is where the hard problem connects, quietly but firmly, to the thread we have been following. If subjective experience cannot be explained by physical description, then it cannot be detected by physical measurement. There is no instrument that registers the presence of inner experience the way a thermometer registers temperature. And if experience cannot be detected from the outside, then the existence of another person's consciousness cannot be verified from the outside. This is not a failure of current technology. It is a structural feature of the relationship between objective measurement and subjective experience. They operate in different domains, and no bridge between them has been found, or some would argue can be found. Solipsism, then, is not merely an eccentric philosophical position. It is a natural consequence of the hard problem. If the only consciousness you can verify is your own, because verification requires direct access to subjective experience, and you only have that access to your own, then the certainty that others are conscious is, and will always be, a matter of faith rather than evidence. That faith may be well placed, almost everyone holds it, but it remains faith. And in the quiet of a late night, that realization carries a particular weight. There is a thought that visits people late at night, sometimes after watching a particular kind of film, sometimes after reading a particular kind of article, sometimes for no clear reason at all. The thought usually takes the form of a question, and the question is this: what if none of this is base reality? What if the world you experience is a simulation, a computed environment running on some substrate you cannot detect? The philosophical argument behind this was sharpened into formal shape by the philosopher Nick Bostrom in 2003. His reasoning proceeds through 3 steps, and at least one of them, he argues, must be true. Either nearly all civilizations at our level of development go extinct before developing the technology to run detailed simulations, or civilizations that develop such technology choose, for some reason, not to run them, or we are almost certainly living inside a simulation right now. The logic is not easy to dismiss. If it becomes possible to simulate conscious minds, and nothing in physics explicitly forbids it, then any sufficiently advanced civilization could run billions of such simulations. The number of simulated conscious beings would vastly outnumber the biological ones. And if you are randomly selected from the set of all conscious beings, the odds favor you being simulated. What connects this to solipsism is more subtle than it first appears. Inside a simulation, every other person you interact with might be independently simulated, a genuine consciousness running on the same computational substrate, but they might not. They might be simplified, approximations generated to respond convincingly, but without inner experience. In a sufficiently well-designed simulation, you would not be able to tell the difference. The person sitting across from you could be a fully conscious simulated mind or an empty shell that behaves identically, and no test you could run from inside the simulation would resolve the question. The simulation hypothesis, then, does not merely reproduce the problem of other minds, it amplifies it. In a physical universe, you at least have the comfort of knowing that other people are made of the same stuff as you: atoms, molecules, biological neurons. This does not prove they are conscious, but it offers a kind of structural analogy. In a simulated universe, even that analogy dissolves. The substrate is hidden. The architecture is unknown. The rules might be different for you than for the entities around you, and you would have no way to know. There is something else worth noting here, something that tends to get lost in the popular discussion of simulation theory. The question of whether we are in a simulation and the question of whether reality is real may not be as connected as they seem. If a simulated mind experiences genuine consciousness, genuine suffering, genuine wonder, genuine love, then the simulation is, for that mind, reality. The computational substrate does not diminish the experience. The pain is real pain. The beauty is real beauty. The question of whether the underlying hardware is carbon or silicon, biological or digital, may matter less than we instinctively think. And if that is the case, then the deepest version of the solipsism question remains unchanged, whether reality is simulated or not. The question is not about the nature of the substrate. It is about the nature of experience. Do others have it, and can you ever know? The simulation hypothesis does not answer this. It merely removes one more layer of certainty from a question that was already more naked than most people are comfortable acknowledging. In the history of science, there is a pattern that recurs with remarkable consistency. A phenomenon is observed, discussed, debated, and then someone builds an instrument that measures it, and the debate resolves. Temperature was a source of philosophical confusion until the thermometer was invented. The existence of atoms was disputed until electron microscopy and mass spectrometry made them visible. The age of the universe was uncertain until cosmic microwave background radiation was measured with precision. Measurement is, in many ways, the defining act of science. It is what transforms speculation into knowledge, argument into evidence, belief into fact. And it is the absence of a particular measurement that keeps the solipsism question permanently open. Neuroscientist Christoph Koch, one of the leading researchers on the neural correlates of consciousness, has noted that we lack a consciousness meter, a device that can reliably detect the presence or absence of subjective experience in a system. We do not have one for other humans. We do not have one for animals. We do not have one for artificial intelligence systems. And we do not have a clear idea of what such a device would even look like. This is not simply a technological challenge. It is a conceptual one. A thermometer works because temperature can be defined in terms of molecular motion, and molecular motion can be measured, but consciousness has no agreed-upon definition in physical terms. We know it when we experience it. We can describe its neural correlates, but we cannot point to a physical quantity and say, "This is consciousness measured in these units." Integrated information theory, developed by the neuroscientist Giulio Tononi, has attempted to create such a measure, a quantity called phi, that represents the degree to which a system integrates information. A high phi in this theory corresponds to a high degree of consciousness. But the theory remains controversial, and calculating phi for any system more complex than a handful of neurons is computationally intractable. It is a theoretical compass that does not yet work in practice. Without a consciousness meter, every claim about which systems are conscious and which are not remains, in a strict empirical sense, unverified. When you assume that the person sitting across from you is conscious, you are making an inference, a very reasonable one, but an inference nonetheless. When you assume that a dog is conscious, but a thermostat is not, you are drawing a line based on intuition and analogy, not on direct measurement. And here, perhaps, is where the scientific and philosophical threads finally converge. Science, the most powerful tool for knowing that humans have ever devised, reaches a wall when it turns to the question that matters most intimately to each of us, whether anyone else has an inner life, whether the universe contains other islands of experience or just one. The wall is not made of insufficient technology. It is made of a deeper limitation The fact that subjective experience is, by definition, accessible only from the inside. No external instrument can reach it. No equation can describe it. No theory, however elegant, can bridge the gap between the measurable and the felt. And so, the solipsism question persists, not because it is likely true, not because anyone endorses it, but because one tool that could refute it, a way to verify the inner life of another being, does not exist and may not be possible. In the silence left by that impossibility, something strange happens. The question stops feeling like a threat and begins to feel like an invitation to sit with uncertainty, to notice how deeply your daily life depends on a trust that has no proof behind it, and to find in that unproven trust something that might be worth calling faith. Suppose for a moment that solipsism is true, not as a philosophical exercise, not as a thought experiment to be dismissed, but as the actual structure of your existence. You are the only conscious being. Every person you have ever spoken to, every friend who has comforted you, every stranger whose face you passed on a crowded street, none of them have an inner life. They move, they speak, they seem to react, but behind the surface there is nothing. The universe is a vast and intricate experience unfolding for an audience of one you. What would change? Here is the strange part. The answer, when examined honestly, is almost nothing. You would still feel love. The warmth that rises in your chest when someone you care about enters the room would be the same warmth. The ache of missing them would be the same ache. The fact that they are not, in this scenario, truly conscious does not diminish the experience you have of them. Your joy is your joy. Your grief is your grief. The emotions do not depend on the independent reality of their objects. You would still find music beautiful. A piece of music has no consciousness of its own, and yet it moves you. The beauty is in the listening, not in the thing being listened to. If the entire external world were a kind of music, a complex, evolving composition experienced by a single awareness, the beauty would not be reduced. You would still make moral choices, even in a solipsist universe. The version of you that treats the apparent others with kindness is a different version of you than the one that treats them with cruelty, and you would have to live inside the version you choose. Morality in this scenario does not collapse. It becomes a question about what kind of inner world you want to inhabit. This is perhaps the most unsettling thing about solipsism. Not its bleakness, but its indistinguishability from ordinary life. The most terrifying philosophical position turns out to be experientially identical to the one you already hold, which raises a question that cuts the other direction. If solipsism would change nothing about your experience, then what does the conviction that others are real actually give you? It gives you, perhaps, a sense of shared weight, the feeling that your joys and sufferings are not isolated events, but part of a larger fabric, that you are not carrying the universe alone. And that sense of company may be the most important thing a belief can provide, regardless of whether it can be proven. The weight of being the only one is not in the loneliness of the fact. It is in the loneliness of the possibility, and the fact that you feel that weight at all, that the thought of cosmic solitude is heavy rather than trivial, tells you something about the kind of consciousness you are. Right now, at this very moment, something extraordinary is happening. You are hearing words, perhaps through speakers, perhaps through headphones, perhaps in a voice that has become familiar over the course of this night. And those words are not merely sounds, they are producing meaning inside your mind, not the same meaning that existed in the mind that composed them. Not an exact copy, but something close enough, something resonant enough, that a kind of contact is occurring across the gap between two subjectivities. This is what language does. And it is, if you think about it carefully, one of the most remarkable things that any living system has ever accomplished. Consider the mechanics. A thought arises in one mind, a private, subjective, neurological event that is accessible to no one else. That thought is then encoded into a sequence of sounds or symbols. Those sounds travel through air, compression waves, nothing more, and arrive at another nervous system where they are decoded into a new thought, a different thought in a different brain, shaped by different memories and associations. And yet something transfers, not perfectly, but well enough for two beings to coordinate, to plan, to comfort, to wound, to build civilizations together. Language is in this sense an anti-solipsism technology. It is a daily, moment-by-moment practice of assuming that other minds exist and that communication between them is possible. Every sentence you utter is an act of faith, a wager that the sounds you produce will create an experience in someone else that bears some relationship to the experience that prompted you to speak. There is a philosopher's observation, often attributed to Ludwig Wittgenstein, that the limits of my language are the limits of my world. Taken in the context of solipsism, this becomes something deeper. If language is the primary bridge between subjective worlds, then the edges of what you can say are the edges of what you can share. Beyond that boundary, each mind is sealed in its own privacy. And yet, here we are. Language works, not perfectly. Every misunderstanding, every argument, every moment of talking past each other is evidence of its imperfection. But it works well enough to sustain relationships, cultures, scientific communities. It works well enough that you can lie in the dark, listening to a voice you have never met, and feel a flicker of recognition. A sense that the thoughts reaching you were shaped by something that shares at least part of your inner architecture. Perhaps this is the gentlest argument against solipsism. Not a logical proof, not a scientific demonstration, but a lived practice. Every time you listen and understand, every time words land in your mind and produce something that feels like contact, you are enacting the assumption that you are not alone. And the fact that this practice sustains itself day after day, year after year, across every human culture that has ever existed, carries a quiet weight of its own. The words you are hearing right now are a bridge. They may not prove that another mind exists, but they are structured as though one does. And the choice to listen, to allow meaning to form, to let the voice in, is itself a small, continuous act of trust in something beyond your own awareness. There is a way of thinking about science that most scientists would find uncomfortable. Not because it is wrong, but because it sits at an angle to the story they usually tell about their work. The standard story goes like this. There is a world out there, independent of us, governed by laws. Science discovers those laws. The process is imperfect, iterative, self-correcting, but the goal is clear. We are trying to describe a reality that exists regardless of whether anyone is looking. But what if each observer's reality is, as several of the frameworks we have explored tonight suggest, at least partially private? What if the facts of quantum mechanics are relational, or perspectival, or personal in the way Cubism describes? Then science cannot be a mirror held up to an objective world, because there is no single objective world to reflect. Instead, science becomes something else, something arguably more interesting. It becomes a negotiation, a collaborative process in which separate experiences, each locked in their own subjective reality, compare notes and search for patterns that hold across their private worlds. It becomes in a sense collective dreaming, a shared effort to construct a model that is consistent enough, stable enough, and useful enough that all the dreamers can operate within it. Christopher Fuchs, the architect of Cubism, has used the phrase participatory realism. It captures the idea without the mystical connotations. Science, in this view, is not discovering a pre-existing truth. It is participating in the construction of a shared reality. Each experiment, each observation, each conversation between researchers is a thread woven into a tapestry that no single person can see in its entirety, but that all of them are co-creating. This does not make science less valuable. If anything, it makes it more remarkable. Consider what it means. Billions of separate conscious beings, each locked inside their own nervous system, each experiencing a private version of the world, have managed to develop a process so rigorous and so disciplined that it produces results everyone can use. Airplanes fly, medicines work, satellites orbit. The model is effective, even if it is not. In the deepest philosophical sense, a photograph of an independent reality. There is a precedent for this kind of thinking in the history of science itself. The physicist Niels Bohr insisted that physics does not describe nature as it is. It describes nature as we ask questions about it. The philosopher Thomas Kuhn argued that scientific paradigms are not progressively more accurate pictures of reality, but different frameworks for organizing experience. None of this undermines the power of science. It merely reframes what that power consists in. And this reframing carries a strange kind of comfort. If the question of whether you are the only real person leads to the recognition that science is a collective participatory construction, a shared dream negotiated between separate minds, then the very existence of science is in itself an act of trust in other consciousnesses. Every published paper, every replicated experiment, every peer review is premised on the assumption that other minds exist, that their observations matter, and that their experiences are real enough to count. Science does not prove you are not alone, but the practice of science assumes you are not. And that assumption, held collectively by millions of minds over centuries, has produced the most reliable model of reality that humanity has ever known. There is an experience that almost everyone has had, though it is not easy to describe, and it offers something that no logical argument or scientific instrument can provide. It is the experience of being genuinely surprised by another person. Not the small surprises, a different restaurant choice, an unexpected gift, the deeper kind. The moment when someone you think you know well says something you could not have predicted. When a friend reveals a fear you never imagined they carried. When a stranger, in a brief and unrepeatable exchange, offers a perspective so alien to your own that it cracks open a part of your thinking you did not know was closed. These moments matter because, if you sit with them carefully, they pose a genuine challengito, the solipsist position. A solipsist universe should be, in some important sense, bounded by the capacity of the one mind that generates it. The dream should not exceed the dreamer. The characters in the story should not be more inventive, more surprising, more creative than the author who writes them. And yet other people exceed us all the time. They think thoughts we could not think. They solve problems in ways we would never have approached. They carry experiences so different from ours that hearing about them feels less like receiving information and more like visiting a foreign country. The novelist who claims her character surprised her, who says they took on lives of their own and refused to follow the outline, is describing something that anyone who has spent real time with other people recognizes. Other minds are not predictable extensions of your own. They are wild, strange, occasionally incomprehensible. And that wildness is, in a way, empirical evidence that something beyond your own consciousness is contributing to your experience. This is not a proof. A solipsist could argue that the subconscious mind is vast, and that its products might surprise the conscious mind just as thoroughly as another person does. Dreams, after all, can be surprising. The monsters and strangers that populate sleep are generated by the same brain that is startled by them. So surprise alone does not settle the question, but it shifts the emotional weight. The felt sense of encountering an other, a genuine other, with a genuine interior, is not a minor feature of human life. It is close to the center of it. The relationships that matter most, the conversations that change you, the moments of unexpected tenderness or unexpected conflict, all of them depend on the assumption that you are encountering something real, something that exists independently of your will and exceeds the boundaries of your imagination. Maybe that is the kind of evidence that the solipsism question ultimately turns on. Not logical proof, but lived testimony. Not a theorem, but a texture. The sheer irreducible strangeness of other people, the fact that they are never quite what you expect, is perhaps the closest thing to a counter-argument that experience can provide. It is not conclusive. But then, late at night, beneath a sky full of stars whose light has traveled billions of years to reach your eyes, conclusive may not be what you need. What you need may be exactly this, a reason, however imperfect, to believe you are not alone. Somewhere in the journey of this night, a shift may have happened without your noticing. The question that opened this exploration, what if you are the only real person, may have begun to feel less like a threat and more like something else, something quieter, something almost like a gift, because there is a mercy in not knowing. And it is not the mercy of ignorance or avoidance. It is the mercy of openness, the kind that comes when a question is too deep to answer and too important dismiss, and so you learn to live inside it. Consider what certainty in either direction would cost. If you knew with absolute proof that you were the only conscious being in the universe, the loneliness would be unbearable, Every relationship would be revealed as a monologue. Every act of love would be a gesture made to no one. The weight of it would be crushing. But if you knew with equal certainty that every person around you was fully conscious, if you could feel their inner lives as vividly as you feel your own, something else might be lost. The particular tenderness that comes from choosing to believe without proof, the gentleness that arises when you treat someone as real, not because you must, but because you wish to. The way uncertainty makes each act of kindness slightly more generous, slightly more deliberate, slightly more meaningful than it would be if it were merely obligatory. The not knowing creates a space in which something remarkable can live, a voluntary compassion, an ethics that does not follow from certainty, but from choice. You treat others as conscious because that is the kind of consciousness you want to be, not because the evidence compels you, but because the alternative diminishes something essential in you. There is a resonance here with an idea that runs through many wisdom traditions, though it takes different forms in each. The Buddhist concept of dependent origination suggests that nothing exists independently, that all things arise in relation to one another. The notion that the self is not a fixed entity but a process, continuously formed by its encounters with what it is not. If this is even partially true, then the question of whether other minds are real becomes less about them and less about you, and more about the relationship, the encounter itself. Perhaps the deepest response to solipsism is not a refutation, but a practice. The practice of treating the unknowable as sacred, of meeting each person with the quiet assumption that behind their eyes is a universe as vast and private and irreducible as your own, not because you can prove it, but because the act of meeting them that way is itself a form of meaning-making. You cannot escape the prison of your subjective experience, but you can press your hand against the glass and imagine that someone is pressing back. And the fact that you will never know for certain whether they are, that the glass is forever opaque, might be exactly what makes the gesture matter. At some point during this long, quiet journey, perhaps a few chapters ago, perhaps just now, something subtle may have come into focus. The very fact that you are here, listening, thinking about whether other minds are real, is itself a peculiar kind of evidence. Not evidence that settles the question, but evidence that the question exists, and that it matters to you, and that mattering is not nothing. A stone does not wonder whether other stones are conscious. A river does not ask whether the ocean it flows toward has an inner life. These are not failures of curiosity. They are absences of the kind of awareness that makes such questions possible. The fact that the universe produced something capable of wondering whether it is alone, that is the strange, irreducible starting point. Solipsism, followed all the way to its end, does not lead where you might expect. It does not lead to nihilism or despair or cold isolation. It leads, if you are honest with it, to a kind of heightened attention. If the people around you might not be conscious, then every moment of apparent connection becomes more precious, not less. If the world might be your own construction, then every beautiful thing in it is, in some sense, something you are doing. And the fact that you would construct beauty, that your mind would populate its loneliness with sunsets and symphonies and faces that make your heart ache says something extraordinary about the kind of consciousness you are. The journey we have taken tonight has moved through sealed skulls and quantum laboratories, through thought experiments and philosophical paradoxes, through interpretations of physics that place the observer at the very center of reality. And at every stage, what we found was not an answer, but a richer way of framing the question. The measurement problem did not confirm solipsism. It revealed that the relationship between observer and reality is deeper than anyone suspected. Entanglement did not dissolve the boundaries between selves. It suggested that boundaries might be approximate rather than fundamental. And now, here at the end, the question folds back on itself. The asking is itself the answer, not in the sense that it resolves anything, but in the sense that a universe that contains the asking is not a dead or empty universe. It is one that, at the very least, contains wonder. And wonder, whatever else it may be, is not something that can exist in isolation. It reaches outward even when there is no proof of what it reaches toward. There is an image worth returning to now, near the end of this night. Two particles, separated by a distance that light itself would need time to cross, sharing a state that neither possesses alone. They were once close, once interacted, and now they are entangled, connected in a way that does not weaken with distance, that does not degrade over time, that does not depend on any signal passing between them. We talked about entanglement earlier as a feature of quantum mechanics, a confirmed, experimentally verified aspect of the physical world. But here, in the gentle settling of these final chapters, it is worth letting the image do something different, not as a scientific anchor, but as something closer to a metaphor, though a metaphor rooted in something real. If the fundamental layer of reality is relational, if things do not exist in isolation, but only in connection, as Rovelli proposes, then the separateness you feel as a conscious being may be something like the surface of a lake, visible, tangible, seemingly real, but beneath it, the water is continuous. The boundaries between the waves are boundaries of appearance, not of substance. This does not prove that other minds exist. Nothing can prove that in the way we usually mean the word prove, but it offers a different kind of reassurance. The suggestion that the universe is not built for isolation, that the fundamental grammar of physics is not one of separate objects interacting across a void, but of relations, connections, and shared states. Whatever consciousness is, and we have seen tonight how deeply that question resists an answer, it arises in a universe where separateness is not fundamental, where the space between things is not empty, but woven through with correlations, where two particles on opposite sides of the cosmos remain, in some precise and measurable sense, aspects of a single reality. Maybe that is what the particles already know, if knowing is even the right word. That being apart does not mean being unconnected, that the distance between two things is not the deepest truth about them, and maybe, in a way that no equation can quite capture, the same is true of the distance between minds, the space between you and every other consciousness that may or may not exist beside you in the dark. That space too might be less empty than it seems, not because we can prove it, but because the fabric of reality, as far as we can tell, is not made of gaps. It is made of connections. Let that thought settle. Let it sit alongside the uncertainty, not replacing it, but keeping it company. Every person you have ever loved is someone you cannot verify. Every hand you have held, every conversation that shifted the way you see the world, every quiet evening shared with someone whose presence made the silence feel less vast. All of it rests on a foundation you cannot inspect, the foundation of believing, without evidence, that the being across from you is home. This might sound like a limitation, and in a strict epistemological sense, it is. You cannot bridge the gap between your subjective experience and anyone else's. The wall is permanent, the glass is opaque, but there is another way to see it. Every act of love is an act of faith. Every gesture of kindness directed toward a being whose inner life you cannot confirm is a choice, a free, unforced, unrequired choice to treat consciousness as something worth honoring, even when you cannot prove it exists. You do not love someone because you have verified their sentience. You love them because something in their presence resonates with something in you, and you choose to trust that resonance. This is not naivete. It is one of the most sophisticated things a conscious being can do. It is the decision to grant reality to something you can never fully know. To say, in effect, I cannot prove that you are real, but I will live as though you are, because the alternative is a universe I do not want to inhabit. And perhaps this is where the solipsism question finds its resting place, not in proof or disproof, but in practice, in the daily, ongoing, unremarkable act of treating others as though they contain a universe. Consider the asymmetry. If you treat other people as conscious and they are not, you have lost nothing. Your kindness is still kindness. Your love is still love. The quality of your inner world is not diminished by being directed toward a void. But if you treat other people as unconscious and there, the loss is immeasurable. You have closed yourself off from the very thing that makes existence bearable, the possibility of genuine contact. The wager, then, is not Pascal's wager about God. It is something more intimate. It is a wager about the person sitting next to you, the person you spoke to this morning, the voice that reads these words into the space where you are resting now. You cannot prove they are real, but you can choose to live as though they are. And that choice, quiet, repeated, sustained across a lifetime, may be the most meaningful thing any consciousness can do. The night is deep now. The thoughts are softening, and the question remains, as it always has, beautifully unanswered. There is a moment just before sleep arrives, when the boundary between you and the world begins to dissolve. You have probably felt it. The edges of your thoughts grow soft. The room, which a moment ago felt solid and specific, becomes less certain. Sounds lose their sharpness. The weight of your body on the bed becomes less a fact and more a memory of a fact. And somewhere in that dissolving, you stop doing the thing you have been doing all day long. You stop verifying. You stop checking whether the world matches your model of it. You stop asking whether things are real, and the world does not collapse. It simply continues, but in a different mode, the mode of dreaming, where reality is not tested, but trusted, where strange things happen, and you accept them without question, where the faces of people appear without your having summoned them, and you feel their presence as fully as you feel anything in waking life. This transition from waking to sleep is itself a small enactment of the question we have spent this night exploring. In the waking state, you maintain the assumption that the world is real and that other minds exist, and you test that assumption continuously, unconsciously, with every sensory check and every social interaction. In sleep, you release all of that. You let the assumption go, and what remains is pure experience, unanchored to any external confirmation. Tonight, as you approach that boundary, you carry something with you, not an answer. The question of whether you are the only real person does not have one. What you carry instead is the question itself, held more gently now than when we began. You have seen it reflected in the double-slit experiment, where observation shapes what is observed, in Wigner's Friend, where two realities coexist without contradiction, in Wheeler's participatory universe, where the observer and the observed are woven together, in Cubism, where reality is personal, in entanglement, where separation is not fundamental. None of these resolved the question. All of them deepened it, and there is something in that deepening that feels not like failure, but like coming closer to the actual texture of existence, which has always been more mystery than explanation, more wonder than certainty. The universe, whatever it is, went to extraordinary trouble to produce something that could lie in the dark and wonder whether it is alone. Billions of years of stellar nucleosynthesis, of planetary formation, of molecular complexity building upon itself until something opened its eyes and asked the question. That wondering you're wondering right now, in this moment, is not a flaw. It is perhaps the most remarkable thing the universe has done. Let that be the last thing you hold, not an answer, but the warmth of the question itself. The fact that it matters to you, the fact that you care whether other minds exist, which is itself a form of love extended toward beings you have never been able to prove are there. The question is a gift. You do not need to unwrap it tonight. Let the thoughts soften. Let the edges blur. Let the question be a lantern that dims slowly, not because it has run out of light, but because you no longer need to see. You are not alone in the way that matters. You never were. Rest now. The shared dream is waiting.